Now I want to discuss rest of the questions from NEET 2025 question paper. 31 question. Which one of the following reactions does not belong to Lassigne's test? 2CuO plus carbon giving rise to 2Cu plus CO2, Na plus carbon plus nitrogen giving rise to sodium cyanide, 2 mole Na plus sulfur giving rise to Na2S, Na plus X giving rise to NaX. We know that nitrogen, sulfur, halogens and phosphorus present in an organic compound are detected by Lassigne's extract. Lassigne's test means sodium fusion extract. So sodium fusion extract or Lassigne's test, by using we can detect or identify nitrogen, sulfur, halogen like chlorine, bromine, iodine, and phosphorus also. But here first reaction, 2 mole copper oxide plus carbon giving rise to 2 mole Cu plus CO2. This reaction is not belong to Lassigne's test, means sodium fusion extract test. So that which option is right answer? Option 1 is right answer. Option 1 is right answer. So you can observe here detection of carbon and hydrogen. So detection of carbon and hydrogen. Hydrogen and carbon can be detected by using copper oxide test. What is the test? Copper oxide test. Copper oxide test. Here, when copper oxide reacts with organic compound containing carbon, then carbon dioxide gas evolved. When this carbon dioxide gas passes through the lime water, it turns milky, means calcium carbonate appeared. For example, copper oxide is treated with organic compound containing hydrogen, then water generated. Then that water passes through the anhydrous copper sulfate, then it will turns blue color, means hydrated copper sulfate, CuSO4.5H2. So this is called copper oxide test. Copper oxide test. By using this test, we can detect carbon and hydrogen. So the first reaction, that is completely different from the remaining three reactions. So option 1 is right answer. Now moving to next question. Now 32 question. How many products including stereoisomers are expected from monochlorination of the following compound? So it is 2-methyl butane. What is its name? 1, 2, 3, 4. What is IUPAC name? 2-methyl butane. Here, how many monochlorinated products are formed? Here, A type, A type. These two methyls are identical. This is B type, C type, D type. Then, how many monochlorinated products are formed? 4. 4 monochlorinated products are formed. I wrote here very clearly. Now, here including stereoisomers, we need to identify. We need to count, including stereoisomers. Now, coming to first compound, here one chiral center is there. So, one chiral center and asymmetrical molecule. So, one chiral center means formula 2 power n. That is equal to 2 power 1, means 2 stereoisomers. So, that is dextro-levo. 2 stereoisomers, dextro and levo. Now, coming to here no chiral center. Second molecule, no chiral center. So, that only one molecule existed, no chiral center. Only one molecule existed. Now, coming to third molecule. Here one chiral center is there. One chiral center means 2 power n, 2 power 1, 2 stereoisomers means dextro levo. Clear? Now fourth one. Here any chiral center is there? No chiral center. All are acyl carbons. No chiral center. So only one stereoisomer existed. Only one compound existed. So no stereoisomers existed because no chiral center. Then 2 plus 1 plus 2 plus 1. So total how many? 6. How many isomers existed? 6. 6 stereoisomers existed. 6 stereoisomers existed. So what is the right answer? Option 1 is right answer. Option 1 is right answer. Now moving to next question. 33 question. Sugar X, statement A, is found in honey. Statement B is a keto sugar. Statement C exists in alpha and beta anomeric forms. Statement D is levorotatory. Then X is it sucrose, D glucose, D fructose, maltose? Here I provided data. Now first one fructose. Here first one fructose. Fructose is an important ketohexose. It is obtained along with glucose by the hydrolysis of disaccharide. So, when sucrose undergoes hydrolysis, you will get glucose plus fructose, like that. So disaccharide sucrose. It is a natural monosaccharide found in fruits, honey, and vegetables. Here, this is important point. So, fructose is found in fruits, honey, and vegetables. So that what is the right answer here? Fructose. Fructose is the right answer. So here, what is the first one found in honey? So from this point, we can recognize which option is right answer here. D, fructose. Now, it is a keto sugar, right? Only it is a keto sugar. It is a keto sugar. You can observe this one. This is keto hexose keto sugar. So that obviously, which is the right answer? Which is right answer? So it is a keto sugar, means yes, D fructose only. Now, next one, exist in alpha and beta anomeric forms. Beta and anomeric forms. Now we can write a Haworth formulas, like Haworth formulas. So this fructose we can be written like Haworth formulas. So alpha D fructofuranose and beta D fructofuranose. 5-membered ring. 5-membered ring means it is furan-like structure. Furan-like structure means furanose. Suppose glucose. Glucose, how can we call glucose? Its cyclic forms. So alpha D glucopyranose, beta D glucopyranose. So that means pyranose, pyran-like structure, 6-membered ring. So here fructose, furan-like structure, furanose. So alpha D anomeric forms existed. So that right one. So it is also related to fructose. Of course, glucose also can form, and fructose also can form. And levorotatory, yes, obviously. So D fructose is levorotatory. Suppose D glucose, that is dextrorotatory. So levorotatory, dextrorotatory, that is experimental value. Okay, experimental data. From experimental data, we can say, suppose it is levorotatory, dextrorotatory, like. So glucose is dextrorotatory, but fructose is levorotatory. So here you can observe now, here alpha anomeric form, beta anomeric form. Here within the bracket you can get negative sign. This negative sign indicates levorotatory. Suppose for the glucose, within the bracket you can find like positive. Understood? So that from all conditions, what is the right answer? D, fructose is the right answer. So I provided data here from NCERT textbook only. So very useful for you. And here maltose also, I provided maltose and sucrose also. So maltose means alpha D glucose units are present. Maltose, it is a disaccharide. And coming to sucrose, it is dextrorotatory compound actually, but here sucrose is a dextrorotatory compound, but here in conditions given levorotatory, so that sucrose we can eliminate. And sucrose dextrorotatory, but aqueous solution of sucrose is levorotatory. So you can find out data from here. So now moving to next question. Dalton's law, Dalton's atomic theory could not explain which of the following: law of gaseous volume, law of conservation of mass, law of constant proportion, law of multiple proportion. Dalton's theory could explain the law of chemical combination. However, it could not explain the laws of gaseous volume. So Dalton's atomic theory could not explain laws of gaseous volume. So which option is the right answer? Option 1 is the right answer. So Dalton's atomic theory, it can explain law of multiple proportion, law of conservation of mass, law of constant proportion or definite proportion, but it could not explain gaseous volume. Now moving to next question. Higher yield of NO in N2 plus O2 giving rise to 2NO can be obtained at. Here enthalpy of reaction plus 180.7 kilojoule per mole given. So here 180.7 kilojoule per mole plus. So delta H positive given. Delta H positive given. So delta H positive means it is endothermic reaction. Endothermic reaction. So endothermic reaction, we can remember like endothermic and endothermic high temperature, endothermic high temperature forward direction. This is very important point. Suppose exothermic low temperature forward. So this line is very important. Suppose exothermic low temperature forward. These two lines are very important. So endothermic high temperature forward, exothermic low temperature forward. So it is endothermic reaction. It is endothermic reaction. So endothermic high temperature forward. But here higher yield in NO means yes, product forward direction. Here forward direction asking. So high temperature forward. So statement A is right. So statement A is right. Next to low temperature, obviously backward reaction favorable. This is wrong. Now high concentration of N2. High concentration of N2. Suppose here N2 gas plus O2 gas giving rise to 2NO gas. So high concentration of N2. So suppose N2 concentration increases, then reactants concentration increases. Comparatively, products lower in concentration. According to Le-Chatelier principle, equilibrium reaction shifting from higher concentration to lower concentration. Then reaction move in forward direction. Understood? So that higher concentration of N2 forward direction. So this is right. Next, higher concentration of O2 also forward direction. O2 also reactant na here. So O2 concentration increases, then reactants concentration increases. Comparatively, products lower in concentration. So that higher to lower means forward direction. So that here higher concentration of N2, higher concentration of O2, that conditions give reaction is in forward direction. So that A right, C right, D right, A, C, D correct. Then which option is the right answer? Option 1 is right answer. Statement A, C, D. Right means option 1 is right answer. Then moving to next question. Now 36th question. Match list 1 with list 2. List 1 XeO3, XeF2, XeOF4, XF6. And list 2 hybridization and shapes provided. Now first one XeO3. This is the wonderful trick. XeO3, Xe central xenon atom, its group number 18th or 8th A or 0 group elements. So 8 valence electrons are there. We can write like 8 electrons, and 3 oxygen atoms are there. Oxygen divalent atom, 2 electrons required. then 3 oxygens we can connect like, then remaining electron pair is like lone pair. So just count the here atoms plus lone pairs. Just you can count atoms plus lone pair. So 3 atoms plus 1 lone pair, 4. 4 means sp3 hybridization. So this is the trick only, okay? This is the trick. Okay, this is the trick. Best trick. Okay, so what is the molecule? How can we write structure? Xe. So 3 oxygens, 3 double bonds, and 1 lone pair. So it is pyramidal shape. Pyramidal shape. Now moving to XeF2. Same you can write like central xenon, 8 valence electrons. Fluorine, you know, monovalent, 1 electron required. Remaining 6 electrons means 3 lone pairs. So already I told you atoms plus lone pairs you can count. So 2 bond pairs, 3 lone pairs, total 5, sp3d. You know, according to valence shell electron pair repulsion theory, bulky atoms or lone pairs always trying to occupy equatorial positions to get less repulsive forces for more existence of a structure. So 3 lone pairs we can write in equatorial position, equatorial, because in between 2 equatorial position bond angle 120 degree, so that more bond angle, less repulsive forces, more existence. Remaining 2 fluorines you can write top bottom axial. So this is a linear shape. This is linear shape. So sp3d hybridization linear shape. Now moving to XeOF4. Similarly, xenon 8 electrons, oxygen divalent 2 electrons required, 4 fluorines 4 single electrons, remaining 1 lone pair. So just you can count 5 atoms plus 1 lone pair, 6. 6 means sp3d2. So it is a square pyramidal shape. Now moving to XeF6. Xenon group number 8 electrons, then 6 fluorine atoms require 6 electrons and 1 lone pair. Total how many? 6 lone pairs plus 6 bond pairs and 1 lone pair. Total how many? 7. Total how many? 7. 6 bond pairs plus 1 lone pair. Total how many? 7. 7. 7 means, sp3d3. sp3d3. Clear? sp3d3. 7. So it is a distorted octahedral. So because presence of 1 lone pair, that perfect octahedron geometry disturbed, shape disturbed. So that's why it is a distorted octahedral. So it is not geometry, shape, distorted octahedral. Okay, because of presence of lone pair, its shape disturbed, octahedral shape disturbed. That's why distorted octahedral. Then which option is the right answer? Once verify which option is the right answer. So XeO3. Okay, XeO3 is matched with sp3 pyramidal. XeF2 is matched with sp3d linear. XeOF4 it is matched with sp3d2 square pyramidal. XeF6 it is matched with sp3d3 distorted octahedral. Then option 2 is right answer. So I hope understood the solution. Then moving to next question. Match list 1 with list 2. List 1. Example: humidity, alloys, amalgam, smoke. List 2. Type of solution: solid in solid, liquid in gas, solid in gas, liquid in solid. So then which one is the right answer? Which option is the right answer? Here option 3 is the right answer. So humidity, so that is liquid in gas. Liquid in gas. Humidity, that is liquid in gas. Alloys, solid in solid. Alloys, solid in solid. So brass, bronze like. Amalgams, amalgams. So liquid in solid, liquid in solid. Smoke, that is solid in gas, solid in gas. So understood. So which option is right answer? Option 3 is right answer. Option 3 is right answer. Now moving to next question. Energy and radius of first Bohr's orbit of helium plus and lithium 2 plus are. Here Rydberg constant given 2.18 into 10 power minus 18 joule per atom, and A naught value means Bohr's radius 52.9 picometer. So this Rydberg constant and A naught values provided for getting. So these are the hint for which formula we have to take. From this hint we can identify which formula we have to take. 2.18 into 10 power minus 18 Z square by N square joule per atom. That formula we can take for energy. And radius 52.9 N square by Z picometer. So very clearly given hint. From that hint, we can choose which formula is best. Yeah. So energy of first Bohr's orbit of helium plus, here I provided a very detailed solution, clear solution. So energy of first Bohr's orbit of helium plus, first Bohr's orbit means first orbit n equal to 1, helium plus Z equal to 2. So you can calculate like minus 2.18 10 to the power of minus 18 into Z square by N square. So Z square 2 square 4, N square 1 square 1 into 4 by 1, then minus 8.72 into 10 power minus 18 joule per atom. This is energy of first Bohr's orbit of helium plus. And radius of first Bohr orbit of helium plus. So n equal to 1 and helium plus for that Z equal to 2. So formula radius of orbit is equal to 52.9 into N square by Z picometer. Then 1 square 1 by Z means 2. So 52.9 into 1 by 2 picometer means 26.45 picometer. Similarly, we can calculate for lithium 2 plus. Lithium 2 plus. Similarly, we can calculate for lithium 2 plus. N value 1 and N value 1. And here for lithium 2 plus, what is the Z value? For lithium 2 plus, Z value 3. Lithium 2 plus, Z value 3. Clear? So energy we can calculate like minus 2.18 into 10 power minus 18 Z square by N square joule per atom. Minus 2.18 10 power minus 18, Z value 3 square 9, N value 1 square 1. So into 9 by 1. So minus 19.62 into 10 power minus 18. Now radius, N equal to 1 for lithium 2 plus Z equal to 3. So radius we can calculate like, so 52.9 into N square by Z picometer. So 52.9 into N value 1 square 1, Z 3. So 52.9 into 1 by 3, then 17.63 picometer. So this is the required solution for helium plus and lithium 2 plus, energy and as well as radius. So which option is right answer? Here 4 values, we got 4 values. Then which option is right answer? Option 2 is right answer. Option 2 is right answer. So lithium 2 plus energy minus 19.16 10 power minus 18 and radius 17.63. 17.63. So correct. And coming to helium plus, energy minus 8.17 10 power minus 18 and radius 26.45. This data. So obviously option 2 is right answer. So I hope understood this solution. Then moving to next question. Which among the following electronic configurations belong to main group elements? Main group elements means representative elements. Main group elements, representative elements, both are same. representative elements. Representative elements. Main group elements are representative elements means, S block and P block elements together are called representative elements or main group elements. Representative elements are main group elements. Understood? So S block and P block elements together are called representative elements. Now neon 3s1, that is sodium, S block element, so it is a representative element or main group element. Argon 3d3 4s2, vanadium, D block, it is not representative element, it is a transition element. And krypton 4d10 5s2 5p5, iodine, it is a P block element, representative element. Argon 3d10 4s1, it is a copper, D block element, it is a transition element. Radon 5f0 6g2 7s2, it is thorium, F block element, it is inner transition element. So that A and C are correct. Okay, A and C are main group elements or representative elements. Then which option is right answer? Option 3 is right answer. Option 3 is right answer. A and C only. A and C only. So understood this solution? Easy question only. Then moving to next question. Carbon plus 2 moles hydrogen giving rise to CH4. Enthalpy of reaction minus 74.8 kJ per mole. Which of the following diagrams gives an accurate representation of the above reaction? So here delta H value minus 74.8 kJ per mole. That means delta H value negative given. Negative value given. So delta H negative means it is exothermic reaction. It is exothermic reaction. Exothermic reaction means heat liberated or evolved. Exothermic reaction means heat liberated or evolved. So from this data we can identify exothermic means how graph is like reactants higher in energy, products lower in energy, then only heat liberated. So reactants should be in higher in energy, products lower in energy, then only heat liberation takes place. Suppose the reactants lower in energy, products higher in energy means heat absorption takes place. That graph represents for endothermic. So here exothermic na reactants higher in energy, products lower in energy. So that which graph is right? Here reactants lower in energy, products higher in energy. First graph wrong, and third graph also wrong. Reactants lower in energy, products higher in energy means heat absorption takes place. So here option 1 wrong, option 3 wrong. Maybe option 2 or 4 right. Now here delta H minus 74.8 kJ per mole means that much of heat liberated. So that which graph is right answer here? Representation is right. So option 2 is right answer. Actually here in option 4 74.8 that gap is given like means it represents activation energy. It is activation energy. So that is wrong. Here this much of heat liberated means here this is right, this is correct representation. So graph okay, this is the potential energy, this is the reaction coordinate, exothermic means it is like, reactants higher in energy, products lower in energy. This is the transition state or energy barrier, and this is activation energy forward, and this is activation energy backward, activation energy backward. And you know this much of heat liberated, delta H equal to how much? 74.8, 74.8. This much of energy liberated. This gap indicates how much heat liberated. Okay, so that which graph is right answer? Option 2 is right answer. Option 2 is right answer. Option 2 is right answer. Here 4 also wrong. So I hope everyone understood this solution. Then move to next question. 41 question. Predict the major product P in the following sequence of reactions. Here 1-methyl cyclopent 1-ene. When this is reacted with HBr, presence of benzoyl peroxide. Hydrogen bromide, presence of peroxide means it follows anti-Markovnikov's rule. So anti-Markovnikov's rule means negative part of the reagent is added to more substituted carbon, means less substituted carbon, that means more hydrogen containing carbon, and positive part of the reagent is added to more substituted carbon, means less hydrogen containing carbon. So simply terminal alkyl bromides are formed. So anti-Markovnikov's rule means negative part of the reagent is added to more hydrogen containing double bonded carbon or less substituted carbon. Positive part of the reagent is added to less hydrogen containing carbon or more substituted carbon. So then break pi bond. Here you can add hydrogen, here bromine. Now second reagent reacts with KCN, potassium cyanide. Then it is a nucleophilic substitution reaction. Now in the place of cyanide, in the place of bromine, you can substitute cyanide. Now potassium bromide eliminated. This is nucleophilic substitution reaction. In the place of bromine, you can write cyanide. Suppose here silver cyanide is there, we will get isocyanide. Here potassium or sodium cyanide, we will get cyanide. Now sodium amalgam ethyl alcohol. If we treated with sodium amalgam ethyl alcohol, this reagent also Mendius reagent. What is this reagent? Mendius reagent. This reaction is also known as Mendius reaction. So that that cyanide is reduced to primary amine. Cyanide is reduced to primary amine. Cyanide is reduced to primary amine. CH2 single bond NH2. So cyanide reduced to primary amine. Then which option is right answer? Option 2 is right answer. Option 2 is right answer. Option 2 is right answer. So this is right answer. Clear everyone? I hope understood. First HBr benzoyl peroxide means anti-Markovnikov's rule. Next treated with KCN, nucleophilic substitution, cyanides are formed. Then cyanides reduced to primary amine. Just C triple bond N. So just break 2 pi bonds, add hydrogen atoms, CH2 NH2. So then which option is right answer? Option 2 is right answer. Then moving to next question. Identify the correct orders against the property mentioned. H2O is greater than ammonia is greater than chloroform, dipole moment. So, H2O 1.85, ammonia 1.47, chloroform 1.04. Then this statement is right. Dipole moment order is right. Here depends on polarity also. Bond polarity also we can decide. Water molecule 1.85. Water molecule 1.85. Water molecule, it is bent shape. Two bond pair polarities and two lone pair polarities all are working in same direction. Dipole moment is directional property. So that's why all bond pair polarities, lone pair polarities are same in direction. And of course, OH is more polar bond, more electronegativity difference is there as compared to NH and next to chloroform CCl. That's why it has greater dipole moment 1.85. 1.85 dB. Next to ammonia. It is pyramidal shape. It is a pyramidal shape. But as compared to NH bond polarity, OH bond polarity is greater. That's why water molecule has greater dipole moment than ammonia. Here, nitrogen more electronegative than hydrogen. Nitrogen more electronegative than hydrogen. Here also lone pair is working out of the plane. All are working in same direction. So, all are working in same direction. So, it is also greater dipole moment, but obviously it is less than water molecule 1.47 dB. Now chloroform CHCl3, chloroform CHCl3, but here CCl bond polarity it is less as compared to OH and NH bond. So this is the reason its dipole moment we can expect less, 1.04 dB. So this is the reason here the given order is right. Now moving to next statement, XeF4 is greater than XeO3 is greater than XeF2. Number of lone pairs on central atom. XeF4 is square planar. XeF4 is square planar. So xenon group number 8 electrons. Now fluorine, 4 fluorine atoms require 4 single electrons. This is one lone pair. This is one lone pair. 4 bond pair, 2 lone pair, then 6. 6 means sp3d2. So from this only we can identify. So on central atom, how many lone pairs? 2 lone pairs. No need to write structure. This trick is enough. On central xenon atom, how many lone pairs? 2 lone pairs. Now coming to XeO3. Xenon 8 electrons, central xenon 8 valence electrons, oxygen divalent 2 electrons required, and 1 lone pair. So on central atom 1 lone pair. On central atom 1 lone pair. Now XeF2. Xenon 8 valence electrons. 2 fluorine atoms required 2 single electrons. Lone pair. It is a linear shape. Already this option related in one matching previous question. So now how many lone pairs? 3 lone pairs. Now on central atom XeF4 2 lone pairs, XeO3 1 lone pair, XeF2 3 lone pairs. Then is it correct order or not? Once verify. So XeF4 how many lone pairs? 2 lone pairs. XeO3 1 lone pair, XeF2 3 lone pair. So this is the wrong order. Now moving to next statement to OH bond length is greater than CH bond length is greater than NO bond length. I provided here just elements order, just elements order means according to periodic table. So hydrogen, helium, they are first period elements. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, second period elements. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, third period elements. You know, hydrogen first period element. Here required atoms, here bond order of bond length na nitrogen, oxygen, carbon, hydrogen. So these four atoms required. So hydrogen, carbon, nitrogen, oxygen. Atom size, radius across the period from left to right decreases, and atomic radius from top to bottom in vertical column group top to bottom increases. In group, down the group increases radius, in across the period decreases, radius decreases. So here size or radius, carbon is greater than and nitrogen is greater than oxygen. So of course hydrogen, that is first period element, very smaller atom. This is the reason OH bond length is very less. OH bond length is very less. And here NO given, nitrogen or oxygen, both are second period elements. Definitely as compared to CH bond length, NO bond length definitely slightly greater. So NO is greater than CH greater than OH. So nitrogen, oxygen both are second period elements now. So as compared to hydrogen, okay, as compared to hydrogen, its size is somewhat big, atom size big, then bond length also slightly greater. So NO is greater than CH is greater than OH. NO is greater than CH is greater than OH. So this is the wrong. Now bond enthalpy, you know very well, N triple bond N and O double bond O and H single bond H. You know, bond order increases and bond dissociation energy or bond enthalpy also increases. Required bond enthalpy also increases. Bond order directly proportional to bond dissociation energy or bond enthalpy. So that it is right. Then which statements are right? A and D. Which one is right answer? A and D. Option 2 is right answer. Which is right answer? Option 2 is right answer. Option 2 is right answer. Clear? So I provided very clear data. So you can observe all these key points. I hope everyone understood this solution. Which option is right answer? Option 2 is right answer. Now moving to next question. Total number of possible isomers, both structural as well as stereoisomers, of cyclic ethers of molecular formula C4H8O is. So particularly, exclusively, we should write cyclic ethers C4H8O. So you know, degrees of unsaturation. What is the formula? 2C plus 2 plus nitrogen minus H minus X by 2. So from that we can get 1. That means this molecular formula in its structure, it is having one ring or one pi bond. So of course here cyclic asking na, that's why one ring. Obviously degrees of unsaturation 1 means that should be one ring. Of course here asking cyclic ethers na, that's why. So then how many cyclic ethers are existed including structural stereo? So now first one, so here C4H8O na, then including 4 carbon atoms, so 4 carbon atoms with including oxygen, then it is 5-membered ring. So first 5-membered ring. You can think like, so first 5-membered ring. So only one compound existed. 5-membered, only one compound. With the 4-membered ring, 5-membered ring, one compound. So with 4-membered ring including oxygen, only 2 structures existed. So only 2 structures existed. So you can write methyl here and you can write methyl here. Only two structures existed. And you know, with three membered ring, how many structures existed here? How many structures existed? You know, this is one structure, and this is one structure, methyl, two methyl groups in same side means cis, and we can write like trans. We can write like trans. This is one compound existed, and another compound ethyl. So how many existed here? Four existed. Four compounds existed. Understood? Four compounds existed. So now these are the structural isomers. These are the structural isomers. Of course, here we wrote cis and trans, na? They are geometrical isomers. So here we wrote structural isomers possible, and cis trans also we have written. Now we have to verify stereoisomers. Now first compound, no chirality, means only one compound existed. That one compound only existed. Now moving to this molecule, here one chiral center existed, na? That means dextrolevo, two compounds existed. But moving to this compound, no chirality, that only one compound only existed. Now coming to this molecule, this is also achiral compound overall, no chiral carbon, so only one compound existed. Now coming to two methyl group, same side we can write here, two methyl groups, opposite side we can write now, so that here cistrons, already we have written here geometrical isomers, here geometrical isomers and optical isomers, both together they are under stereoisomers. Is it right? Okay. So two methyl same side, now this is cis. Here plane of symmetry existed. Here plane of symmetry existed. Is it right? Cis, na? So plane of symmetry existed. So exactly plane of symmetry. So plane of symmetry existed means we can call it as cis compound. Sorry, meso compound. It is cis isomer. So in which plane of symmetry existed. So it is meso compound. It is achiral. Overall compound achiral, optically inactive. So only one compound existed. But coming to next molecule, two methyl groups, opposite side we can write. So it is a trans. Here no plane of symmetry existed. Here no plane of symmetry existed. That's why this compound plus, so here plane of symmetry not existed. Now that's why this compound plus its enantiomer. Its enantiomer. We can write its enantiomer. Means dextrolevo. How many existed? Two existed. How many compounds existed? Two. So in any compound in which plane of symmetry absent, then we can write that molecule, and that's enantiomer. It's enantiomer. So that means mixture of compounds, dextrolevo. So two compounds. Now coming to this compound, here one chiral center only existed. That's why dextrolevo, two stereoisomers existed. Then total how many compounds? Total how many compounds? This is the one with 5-membered ring, and with 4-membered ring 2 plus 1 3 compounds, and here with 3-membered ring, how many? 1 plus 1 plus 2 plus 2. How many total here? 2 plus 2 4, 4 plus 2 6, and 6 plus 3 9, 9 plus 1 10. Total how many stereoisomers? 10 stereoisomers existed. How many isomers existed? 10 stereoisomers. So I hope everyone understood this solution. Now for this compound, for this molecular formula C4H8O, how many stereoisomers existed? 10 stereoisomers. So option 4 is right answer. Option 4 is right answer. 10 stereoisomers. So please observe this detailed solution. Now moving to next question. For the reaction A giving rise to 2B, the backward reaction rate constant is higher than the forward reaction rate constant by a factor of 2500 at 1000 Kelvin. Here R value 0.0831 liter atmosphere mole inverse Kelvin inverse given, and Kp for the reaction at 1000 Kelvin is Kp value we need to calculate. So here Kc equal to Kf by Kb. So Kc equal to Kf by Kb. This is the formula. But here forward rate constant to backward rate constant. Here backward rate constant it is how many times higher? It is how many times higher? 2500 times higher as compared to forward rate constant. As compared to forward rate constant, here backward rate constant how many times higher? 2500 means 2500. 2500. So then Kf by Kb equal to 1 by 2500. So this expression we can use. So then A gas giving rise to B gas. So delta N gas, number of moles of gases moles of products minus number of gases moles of reactants. 2 minus 1, that is equal to 1 mole. Then Kp equal to Kc RT power delta N. This is the required expression formula. So then here Kp equal to Kc. In the place of Kc we can write 1 by 2500 into R value already provided 0.0831 liter atmosphere mole inverse Kelvin inverse, and temperature 1000 Kelvin, and delta N gas power 1. So if we simplify, then we will get 0.033. So what is the answer? 0.033. So which option is right answer? Which option is right answer? Option 4 is right answer. Option 4 is right answer. Okay. Then moving to next question. 5 moles of liquid X and 10 moles of liquid Y make a solution having vapor pressure of 70 torr. The vapor pressures of pure X and Y are 63 torr and 78 torr respectively. Which of the following is true regarding the described solution? Here 5 moles of liquid X and 10 moles of liquid Y make a solution having vapor pressure of 70 torr. This 70 torr is given now. This is observed total vapor pressure of solution 70 torr. Then now we have to calculate calculated vapor pressure of solution or expected vapor pressure of solution. So then here pure liquid vapor pressure is given P0 X 63 torr, P0 Y 78 torr. Then moles also, liquid X how many moles? 5 moles, liquid Y 10 moles. So formula, total pressure equal to P0 A J A plus P0 B J B. So from that we got 73 torr. This is expected or calculated value. This is the calculated value. How much? Calculated vapor pressure of solution 73 torr. But observed how much? Observed how much? 70 torr. So here observed vapor pressure, it is less than calculated vapor pressure. So always we have to focus on observed vapor pressure. As compared to calculated, observed is low. Observed is low means it is a negative deviation. Suppose observed is higher as compared to calculated, that is positive deviation. As compared to calculated value, observed value greater means that is a positive deviation. Observed value is lower. Observed value is lower, negative deviation. Observed value is higher, positive deviation. So here the solution shows negative deviation because observed value is low as compared to calculated value. Here calculated value is 73 torr and observed value that is given in the question 70 torr. The calculated 73 torr. So that it shows negative deviation. So which option is right answer? Option 3 is right answer. So negative deviation, option 3 is right answer. Okay, so these are the questions from NEET 2025. So total questions I explained with detailed solution, and I inserted important data from NCERT textbook also. So I made 3 parts, 3 videos, 3 parts. So you can observe all 3 videos for all 45 questions. So it will help you a lot. So very well how much importance is there NCERT textbook. NCERT textbook is very very important. So every student should read NCERT textbook carefully from line to line, and you can observe one thing from all these questions from NEET 2025, and for each and every question relevant solution, related solution, means each and every question, its data um, is very clearly in NCERT. Not any question is not out of question, not out of syllabus. Okay, so all questions, their solutions you can find out from line to line NCERT, so that everyone, you should read NCERT carefully from line to line, and problems also you can practice NCERT in text questions, and backside exercise questions, everything. So all the best. Thank you so much.